So today's concept is set operators. Okay, so basically these set operators are going to be used to combine two or more select statements of with the same structure. Okay, so these set operators are very important in real time, and we will be using these set operators almost every day in our real time queries. Okay, who are writing any SQL queries, like definitely will be using them, these set operators. Okay, so these set operators basically see in real time world, right? We'll be getting data from different countries, and the same data will be getting from the different countries. So now we are not going to build separate job to load the data, like to load the data which is coming from the to load the same data which is coming from the different countries. What we do is we will be creating one mapping and we'll combine the SQL set result by using a set operator. Okay, let's say when we have a store, general store in our in one location. Okay, for the same organization, when they're going to open a new store in another location, like they're also they'll be having the same software, they'll be having the same backend process, and they're going to store the data in a same tables. Okay, because for every store they are not going to create a separate tables, like they'll be storing into the same tables, but the underlying data will be different. Okay, so sometimes when we are going to get the data from a different tables, for example, ideally we will be storing the data into the same table. There are some situations where the number of transactions of the stores are very huge in size, so that will be very difficult to store the store the data into the same table. That time what we are going to do, region level, the table data will be get stored. When the table data region level it is stored, but underlying structure will be same only. Okay, underlying structure will be same. So when the target table, when we are going to load it, so we are not going to create a separate job to load the data of every table, because the end target is same, but the source tables are also having the same structure, but they are in a different tables. So in that case, what we do, we are going to use these set operators to read the data from multiple sources with the same structure. So basically, set operators are going to be used to combine two or more SQL statements with same structure, Okay, so what are the set operators? Union, union, intersect, and minus. These are the four set operators that we have it in real time. Okay, so what is union? So this union set operator is going to be used to combine the records of multiple tables are having the same structure. So whenever we wanted to use the set operator, any of the set operator, first and foremost thumb rule is all the select statement that we are going to use it between the set operator should be having the same structure. Should be having the same structure. You should not have different structures. Okay, at least on a worst scenario, like these are all the two different tables, and the tables does not have same structure, but still we wanted to combine these two, set up these two with the union. At least we need to make sure the number of columns should be same in the both the select statements. So whenever we wanted to use set operators, the thumb rules that we have to use. First thumb rule. Okay, first thumb rule is both the select statement should have same structure. Okay, if the structure is different, still we wanted to use these set operators, then both the select statement should have same number of columns. Is the first criteria that we will have to see. It should have the same number of columns. So first select statement is having 10 columns, meaning second select statement also should have the 10 columns only. Okay, now if columns are same, then we have to compare the data type. Okay, so first column data type of the first select statement should be same as first column data type of second select statement. Okay, first column data type of the first select statement should be same as first column data type of second select statement. Like that, for every select statement that we will have to compare, for every column we have to compare. So first column data type should be same, second column data type should be same, third column data type should be same. And columns data type should be same in order. Okay, so in the same order, like the data type should be same. And column names must not be the same. Data types are mandatory. Okay, so both select statements can have different column names. Okay, they can have different column names, but the data types are mandatory. So data type should be same. So these are all the 3 thumb rules that we will have to follow whenever we use any set operator. Okay, union, union-all, intersect, and minus. Okay, now let's say let me create few tables. Create table mp_1 as select start from mp where b. So I'm just creating one table with the department number 1, and I'm creating one more table with department number 2. Okay, I have created 2 tables. Select star from emp1, I have this data, and select star from emp2, I have this data. Now I wanted to combine these 2 tables. Okay, what is going to happen when I'm going to use set operators? The first set operator is union set operator. So what union set operator is going to do? It is going to give the unique data between these 2 select statements. Whatever select statements that we are going to write it, so those 2 select statements, it is going to give the unique data. So the distinct values the union set operator is going to give. Let's say I have select star from emp employee table union select star from emp1. So this employee table is having all the data, and this employee 1 table is having only department number 1 data. Okay, now when I'm going to club these two tables, it is going to give the distinct data. See, only 7 records are coming up because all the data whatever is there in the EMP table, that is there in the department table as well. Okay, just for the sake of showing the difference, what I'll do in emp_1 table, let me update. Okay, this so it is going to look for all the data. Okay, it is going to look for uniqueness across all the data. Now select star from employee table, I'm going to get all the data. Select star from emp_1, I'm going to get, it is going to compare both the tables and it is going to give the unique data. Okay, for RAM, if you see, so first 7 records are coming from the first table, and in the emp_1 table also I have two records which are of same values. Because of that, it's not giving this data from this table, and the last record is having a different value. So in EMP table, I have here null. Here I have Hyderabad. So because of that, it's a distinct record. Okay. So whatever the columns that I'm going to specify here, it is going to check for the uniqueness. Okay. Union set operator is going to give the distinct values between two select statements. Okay. Either we can use select star. So select star, so usually right in real time, it is not advisable to go with the stars when we are going to use with the set operators. Always it is advisable to go with the column names. Specify the column names, compare the data types, then execute it. You should definitely use the column names, so that when we are going to mention the column names, we'll be able to see whether the column. So first thing is, by default, what we are going to check is column names are same or not. Even if it is not same, also column data types are same or not, and number of columns are same or not. So these primary things that we can check it when we are going to keep the column names. If we are not going to keep the column names, so we will not be able to check the. Like it will be difficult when we are executing it. It should have the same structure like that. Let's say I have first table, I have 2, 4, 6, 7 columns. Second table, I have 2, 4, 6 columns only. Now I am going to execute this union set operator. See, query blocks are having incorrect number of result set columns, because as I mentioned, both should have the same structure and the same number of columns. Let's say, so instead of employee ID, I'm going to keep the date of birth. So this is one data type and this is one data type. See, the expression must have the same data type as corresponding expression, because number of columns are same. But here, if you see the employee ID data type here is string, and the corresponding column here is date of birth, which is numeric. Okay, so this is why we should maintain data type should be same. Let's say if I'm going to give employee address here, if I'm going to give employee address only here, and here I'm going to give employee ID here. So these two are, the column names are different, but these two are same data types. It will give the result. See, these employee IDs are coming up because the result is giving, even though the column names are different and the values are different, but still they are string data type columns. Because of that, the query will execute, but will give the wrong result. Okay, so that is the reason we should make sure which column that we are populating for which order. The order of the column should be same. Order of data type of the column should be same, and the data of the column should be same. So first, individually, we will have to take each record and we'll have to compare. This is union set operator. Union is going to give the distinct value. See, ideally from EMP table, I have 7 records, and EMP underscore 1 table, I have 3 records. 7 plus 3, 10 records I should get. But 8 records only I'm getting. Why 8 records only I'm getting? Because 2 records are common between these two tables. Next is union all. So union all is not going to look for any uniqueness. Union all is going to give all the data from the first select statement and all the data from the second select statement. That means 7 records from here, 3 records from here, 10 records we are going to get as an output. This is the difference between union and union all. Union is going to look for uniqueness and it will give the distinct data, and union all is going to give all the data from all the select statements. Next is intersect. So this intersect is going to give the common data between these two select statements. Intersect is going to give common records between the two select statements. What are the common records between these two select statements is going to be given by the intersect. Okay, but intersect is very rarely we are going to use them. Okay, intersect will be used very rarely. Okay, but union all minus the next operator are going to be regularly used. Okay, but for interview purpose, we will have to learn this intersect. Okay, so majorly whether we are going to use it in real time or not is secondary, but for interview purpose, whatever the concepts that people are going to ask, those concepts we should be very much familiar. Okay, for intersect, since it is not going to be used in real time, right? So these questions will be coming in interviews. People will think like, so we should ask these kind of a questions so that we can make the person trouble to give the answer. That's how interviewers are going to think. Not all, some of the people. Okay, so these are the intersect set operator. It is going to give the common data between these two select statements. Okay, the next one is minus. So this is the very important set operator, and each and every person should know the set operator. Okay, because this is going to play a major role when we are going to do a unit testing. So once after we complete our development, we as a developer, then we will have to do the unit testing to make sure the data whatever we are loading is correct. Okay, so at least on a high level we will have to check it from a developer standpoint. So this minus is going to play a major role in unit testing. Okay, so what this minus is going to do is, it is going to give the data which is present in the first select statement and which is not present in the second select statement. Minus operator is going to give the data which is present in the first and which is not present in the second select statement. Okay, if you see here.
Again, Bhaskar, please.
Yeah, tell me.
Yeah, please come again.
Yeah, so this whenever we use this minus set operator, it is going to give the data which is present here in the first select statement and the same record if it is not present in the second select statement. Okay, so I'll take an example of it. Okay, so let us assume this is the source table that we are reading the data, and this is the target table what we loaded the data. So the expectation, what could be the expectation? All the one second. Okay, so sorry, what I was telling.
Source data and target data.
Target.
Yeah, let's say in real time when we are loading the data, so this first select statement should be the source and the second select statement should be the target. And when we are loading the data from source to target, so the expectation should be exactly same, like the data exactly same data should be loaded into the target table. Okay, when exactly same data is being loaded, then this minus operator, what it is going to check, so which all the records are coming from here and it is not present here, or if it is not having a proper match, it will look for that. If all the records are exactly matching, this minus is going to give null. It's not going to give any record. Okay, if minus is giving any result, that means the sum of the data is getting filtered out when we are loading the data from source to target, or some of the record does not have a proper match, like some values are not loaded properly. Then we will have to dig into that, why these records are not loading properly. Okay, so how are we going to verify that? I'll explain now. Okay, now when I'm going to execute this minus operator, okay, which are the how many records are there in the first select statement? 7 records. How many records that we are getting it? 5 records we are getting, and 2 records we are not getting because those 2 records are exactly matching. So it is present in the first select statement. It is not present in the second select statement, and vice versa. It is not going to work. Let's say this is having 10 records. This is having 50 records. Okay, so what are the remaining 40 records? It's not going to display. So minus operator always it is working for the first select statement only. It will look for the data whatever is coming from the first select statement, whether this exactly same record is present in the second select statement is not. Only it is going to verify. It's not going to verify vice versa. Okay, always whatever the select statement it is going to be, first select statement result is present in the second select statement or not. So what is going to verify? Let's say if I'm going to keep -1 here, emp underscore 1, this is a apply table. I'm getting 1 record. Okay, so this is the department 1 number data, and ideally the expectation is all the department number 1 data should be present in this table, but there is a difference is coming up. So in this situation, whenever we do minus between source and target, so if the record is coming up, then what we should do is we have to execute the individual select statements with a where condition where employee name equal to from union all. Second select statement employee. See, one is coming from first select statement, the other one is coming from second select statement. Now we are seeing that employee name is same, the same record is there, but employee ID is different, employee address is different. Again, the date of birth and department number also same. So few values are same and few values are having difference. Then we need to identify why the difference is coming up. For what reason this difference is coming up is what that we have to identify. Let's say one is this is the source table and this is the target table. From source we are getting the proper value, but in the target table it is loaded as null. Why it is loaded null? That we will have to verify. Okay, so we have to cross check our mapping why these null values are coming, whether the links are properly connected or not, and is there any truncation between the values, or are we selecting the right columns or right values in the select statement. So there are many reasons, but we will have to see, at least we can identify the issue, whether the data is properly loaded or not. Yes, we can identify. Okay, let's say employee 1 underscore, see the same table I'm going to keep in both the places. This is giving null value because both the tables are having the same values. So whenever, see, here for now I have put the same table. Okay, but like when we assume this is a source table and this is a target table, if both the tables are having the same structure, then the minus is going to give the null value only. So when the minus is giving null, that meaning the data is exactly loaded into the tables. This is one of the primary unit test case that we will have to write as a developer. Okay, any questions here in set operators?
No.
Others?
No, sir.
Fine. After the set operators, we have a concept of constraints. Okay, so these constraints basically they are going to use to maintain consistency data in the database. So in the tables, to eliminate the redundant data which is going to be loaded into the tables, that to avoid that we are going to use these constraints. So these constraints are of different types and they are going to be specified at the different levels. Okay, what are the different types that we have? Not null, check, unique, primary and foreign key, and we do also have a default constraint. So default is not a constraint. Yeah, default is also one more constraint that we have. So these are the 6 constraints that we have in the database. Okay. So these constraints, at what are the different levels that we are going to keep it? At the column level, at the table level, at the alter level. Okay, so column level meaning each and every constraint can be specified for different columns data. Table level meaning, so at the table level we can specify the columns, so we can specify the constraint on top of a single column or a multiple columns. That we will call it as table level. Whenever we are defining the column, defining the constraints immediate next to the column name, that we will say it is a column level constraint. When we have to specify the constraints at the table level, okay, like after the create table structure at the end, we can create, guys, please call me.
কি করেছো দেখি কি পাল্টালো
Okay, at the column level we can specify the constraints, at the table level we can specify the constraints, and alter level meaning once we create a table. So for the first time when we created a table, that we specify, like we forgot to specify the constraint, or we did not had a requirement to specify the constraint, but later we got a requirement to add a constraint. So in that case we should go with alter level. We can alter a table to create the constraint. So that we will say, so these are the, when we can add these constraints at these three levels: column level, table level, and alter level. Now not null constraint. So this not null constraint is going, like whenever we define this not null constraint on top of any column, it will not allow to insert any null values. Let's say we have an employee ID. So when we have an employee ID, so for every employee ID, for every employee should have an employee ID, and it should be a mandatory field. Okay, when it is a mandatory field, that should have this kind of a constraint, not null constraint, to make sure it should not having any null values. Whenever any null value is trying to insert also, it should throw an error stating that, so I am not allowed to insert null values, because not null constraint will be defined, and this not null constraint will be defined only at the column level. Okay, so not null constraints we are going to define at the column level, and it will not allow any null values. Let's say I am creating a table emp underscore cynS means constraint. Okay, so I'm going to have only these columns. Okay, employee ID, employee name, salary, address. Now when I'm going to specify not null here, okay, when I'm going to create a table with the not null constraint, okay, and when I try to insert any value, insert into values, let's see if I'm going to, if I try to insert a null value, and employee name is current employee address is and department number is 1. When I try to insert a null value to this employee ID field, see it is throwing an error stating that cannot insert null into employee ID field, because non-null constraint is defined here. Now I'm going to keep 1, it will insert. See, that record is coming up, because we have defined a not null constraint on top of a column, so it will not allow to insert any null values. Let's say if I'm going to have null value in the other column, it will insert, because it is not going to look for null value, because this column is not a normal constraint column. This column is not a normal constraint column, so that it is going to allow null values. So whenever we have any normal constraint is defined on top of any column, so then it is going to, it will not allow any null values. Okay, either we can keep constraint name column name immediate to the constraint name, or in a real time we should use this syntax. So we have to specify the constraint name for every constraint. We have to specify. If we are not going to specify the constraint name, it is going to create the system generated constraint name. Okay, now when I'm going to constraint, if I go to, where is this constraint tab? Okay, so there is a constraint name is generated, sys underscore C004023. Okay, employee ID is not null. Okay, so it will verify for this condition. Okay, it should not be null value. System generated name will be generated. So if any system generated name is coming up, so there will be a drawback here. What the drawback is, when we are going to upper environments, like from development to testing and testing to UAT and UAT to production, we are going to use the same table structure. So when we are going to use the same table structure, and it is going to generate the same constraint, but with the different names, because the constraint name is system generated name. So at every environment will be having a different constraint name. After few days, or after few months, or after few years, if at all we get a requirement, to drop that constraint. Okay, I don't want this content to be on top of this column, no longer to be used, because my system is pretty much good, so that my table does no need to have any constraint. So we have to drop the constraint. So when we have to drop the constraint, we will have to generate a drop constraint. We have to give a drop constraints. We have to prepare a drop constraint statement. So when we are preparing that, so first we will execute in the dev environment, and we should know that constraint name. So in dev environment, with the name whatever is there, that we will drop it. And when we are going to the upper environment, like testing, UAT, or production, we should not change the script. We should not change the script. We should use the same script. So, but the constraint names are different in the other environments. That time we cannot drop the constraint, because in real time, whatever the scripts that we are going to use it in the dev environment, so people will assume that it is a validated script, and we should use the same script. We should not touch that script when it is going to the upper environments. In that case, we cannot, without changing that, we cannot drop the constraint. So to avoid that, to avoid this kind of discrepancies or difficulties, so always it is advisable to go with the constraint name. So whenever we are going to define the constraint, we should define with the constraint name. Let's say I'm going to drop this table. I'm dropping this table. So when I've defined constraint emp id not null is the constraint name. Emp id underscore not null is the constraint. So we have to specify like this: constraint name, and what is this constraint is what we have to verify. So now the table is created, and when I try to insert a record here, it is inserted because the not null constraint is specified here. Now when I refresh this, earlier it was sys underscore C0 is there. Okay, now if you see, emp id underscore not null is coming up. Okay, because this is the constraint name that we have specified. So when we are going to use the same script across all the environments, it is going to create with the same constraint name, so that whenever we wanted to drop this constraint, so that we don't need to prepare multiple scripts. We just need to prepare only one script, and we'll use the same script across all the environments. Okay, any question here?
Sir, can you explain it once again, sir?
Like how much you understood, and what is the point that you understood, or what is not? Like I just wanted to understand which point you did not understand.
This constraint table is creating table drop, sir,
Creating table?
and dropping the table.
No, this table I just dropped it. Okay, because I wanted to create the constraint at the table level. Sorry, with the constraint name. Okay, so that's the reason I dropped this table. Okay, so what I'm specifying here, or what I'm explaining here, is we have a concept of constraint, and the constraint name is called not null. And whenever we define a constraint on top of any column, it will not allow to insert any null value into that column. Because it is going to throw an error stating that cannot insert null into the table of this column. Okay, now when we are defining a constraint, either we can, without the constraint name, also we can define the constraint, or with the constraint name also we can define the constraint. There are two ways of defining the constraint at the column level. So when we are specifying the constraint name, it will be easy to drop when we are going to migrate the code from other environments, because I'm just telling like a real-time possible ways. Okay, when you get into real time, okay, let us assume that you are working in a real-time world. So now what kind of a situations that we are going to face it, and how do you resolve that with respect to this constraint concept? Okay.
Okay.
So the concept is very simple. Whenever we define any constraint to any column, so I mean not null constraint, it will not allow null values. The concept is very simple, single liner. Okay. So if at all the other part is getting confused for you, so just ignore that. Just try to understand. So whenever we define any not null constraint on top of any column, it is not going to allow null values. Okay. So this is not null constraint. And the next constraint is check constraint. So whenever we define a check constraint on top of any column, so it will first verify whatever the value that we are inserting and whether that is matching with the condition that we are specifying or not. So when we are creating a check constraint, we should specify a condition. Okay, so whenever we define any check constraint, so we have to specify a condition. We have to specify a condition here. So when we are trying to insert a record, it will validate against this condition. If this condition matches, then only it will allow to insert the data into the table. If this condition does not matches, it will not allow to insert the table data. Okay, so this check constraint can be created at the column level, immediate next to the column name, and at the table level. So not null constraint we cannot define at the table level, but check constraint we can define at the table level. Table level meaning end of all the columns we can create a constraint. End of all the columns we can create constraint name, and the check condition. Okay, this is also the same way only. Let's say, see, just for the sake of proper explanation, right, I'm just dropping and recreating the table, so that whenever we, because majorly the constraints that will be used while we creating the tables only, so that because this is going to be one-time activities, it's not on a daily basis that we are not going to do. So whenever we define any table, that time only we are going to take these requirements while creating the table. Like, do we need to define any not null constraint or check constraint or primary key, foreign key, default, whatever it is. Okay, so that is the reason every time I wanted to take a new table, so that I'm dropping an existing table and creating a new table. Let's say employee ID constraint name, let it be, and for the department number we can specify just like check department number in 1,2. Department number 1,2. Now the table is created. So when I'm going to insert any record, okay, first I'm trying to insert record with 1. It is inserted. Let's say I'm going to insert one more record with the department number 3. It will not allow because the check constraint is violated. Okay, because the check constraint will verify whether the department number, the values are 1 or 2 only, because we are giving a condition here. Either we can use in, or whether you can use equal to, or whether you can use greater than, less than, all the operators, whatever I have explained, right? All those operators that we can use it here. when we are defining a check constraint. Okay, so when we are without giving the constraint name, if we are going to use, if you are defining the constraint, then it is going to create a system generated name. To avoid that only, we should create with the proper constraint name. Okay, so this is at the defining the constraint at the column level. Now, table level, how are we going to define the constraint is like this. So we are not going to specify here, comma, constraint. Constraint name is CHK is the standard of check constraint. Check department number and give the condition. I'm just stopping the table and I'm creating a constraint which is specified at the table level. Now the table is created, and when I'm trying to insert a record, it will throw an error, constraint violation, because earlier, if you see, check constraint sys dot name is violated. Now it is check underscore department number is violated. So it should be a meaningful name. Okay, so by seeing that, we'll understand at least. So on top of this department number column, there is a check constraint defined. So, okay, if you are seeing here sys underscore c, what we should understand? We cannot understand anything by seeing the name. So we should go to the table structure, and then we have to identify what is the sys underscore. So here now I have two constraints. One is employee ID normal constraint, other one is check constraint, which is on the department number. So this is at the column level, at the table level. So when we are defining the column level, so this we have to keep it. When we are defining at the table level, we have to write at the end. Okay, any question here in the check constraint? How are we going to define at the table level or at the column level, or how this check constraint is going to work? No. Others? Clear? See, here also the
Yes, sir.
concept is very much simple. So whenever we define this constraint on top of any column, the check constraint, it will look for this condition. So whatever the record that we are trying to insert, if that record is matching this condition, then only it will allow to insert. Otherwise, it is not going to allow. That's it. Okay. And next we do also have a default constraint, which is not there in the material, but yeah, I'll explain that. Okay, so default constraint will be used department number. Yeah, now the table is clear. Yeah, default 1. Okay, because earlier there was an extra closed bracket, because of that it is throwing invalid operation. Okay, so default 1. So what it's going to do, so when if you are not defining any value, it will take the value default value as 1. Okay, let's say when I'm inserting some records here, employee name, sorry, employee ID, employee name, and rest of the values I did not inserted anything. One row is inserted, and when you see here, select star from table for department number 1, the value is 1, but I did not insert it because when I'm inserting it, I'm just taking only these 2 columns. Okay, but still I can see here department number is having value as 1. How it is coming? Because we have defined a default constraint here. Default it to 1. So this default default to 1 is going to work only when if you are not using that column while using the insert statement. If you are going to insert this department number column also with null, if you are using this department number value here, and if you are trying to insert with null value, it will take the null. It will take the null value. So it's not going to insert with 1, because the default, how it is going to work, if we are not at all specifying any value, then it is going to take the default value. So if at all we are not going to specify any value while inserting the record, then it is going to take the default value. Okay, if you are specifying any value, whatever the value it is going to take that value only. Okay, so this default also that we will use it in real time. So that is the reason, even though it is not in material, but still I'm explaining it. Okay, and one more constraint is unique constraint. So this unique constraint is going to be used to avoid the duplicate values in the table or in any column. So if at all there is a possibility of duplicate data, and if you wanted to eliminate while inserting itself, then we have to define the unique constraint. Okay, unique constraint is to whenever we define any unique constraint on top of any column, so it's going to it's not going to insert any duplicate values. Let's say I have inserted one record, and when I try to insert the same record again, it is throwing unique constraint violated, because unique constraint is defined on top of employee ID field. Okay, unique constraint is defined on top of employee ID field. So because of that, it's not trying to already we have employee ID is 1, and again when I try to insert employee ID 1, it is not allowing because throwing unique constraint is violated. Okay, because it will not allow. Whenever we define any unique constraint on top of any column, then it will not allow to insert any duplicate values. It will always maintain unique values, but it will allow null values. But it will allow null values. It will allow null values, but it is not going to allow duplicate values. It will allow n number of null values. Again, don't ask that, even there are 2 nulls, null is again a duplicate value, why it is trying to insert. It will allow null values. N number of null values it will allow. But it will not allow any duplicate values. Let's say I'm going to give 2, it will allow, because 2 is a unique number. And when I try to insert the same 2 again, it will throw in there. Okay, so this unique constraint also that we will regularly use it in real time, and so this constraint also that we can define at the column level or at the table level constraint unique underscore empid unique of empid. So we can create the table with unique constraint. Okay, now when I check the constraints, it will look for unique employee ID. Okay. Oh yeah. Employee ID not null constraint is there. Also, I have defined unique constraint. I can define two constraints on top of the same column because they are the two different functionalities. Now, when I try to insert a record here, one row is inserted. And when I try to insert the same record again, to throw a see unique employee ID is violated because we have explicitly given the constraint name, and also it is not going to allow null values. Cannot insert null into because on top of the same employee ID table, I have defined not null constraint. I have also defined unique constraint. So there are two constraints are defined. So because of that, it is not going to allow any null value and it's not going to allow any duplicate value. Okay, so if at all, so this we can at the alter level also we can create. So alter level meaning, so whenever we define any constraint and after that, whenever we created any table without constraint and after that we will have to create a constraint, meaning we can use alter table statement to create or to add the constraints. After the creation of a table, whenever we wanted to define any constraint, so that we can define by using an alter statement. Okay, any question here? These constraints, unique, not null, check, default. Anyone having any question? Not null, check, unique.
No.